Okay, welcome to part C of session 4. In this part, I'm going to focus all on elasticities. Okay, so first, let's define what elasticity means. Okay, so th- uh, this session and next session, we're talking about demand. So this was going to be elasticity of demand. Turns out you can have an elasticity of supply and elasticity with respect to other things, but now it's all demand. So oh my gosh. I just washed the board. It's still wet. Elasticity equals percent change. So demand elasticity is percent change in quantity demanded divided by percent change in price. Okay. This thing, you got to memorize that. Okay. Memorize this formula. And the key thing, remember, quantity is in the numerator. Okay. If there's a way to remember, usually with elasticity, we're trying to predict quantity. So it helps me that helps me remember that quantity is in the numerator. I'm not sure it will other people. I think the key is you just got to remember quantity is in the numerator, price is in the denominator. Okay. Here is an example. Suppose that the price of salt increases by 50%. Okay. So percent change in price for salt is 50%. Okay. Now the book talked about this, that there are some things, if something makes up a small part of a person's budget, um, that person is probably not that sensitive to price. So we'll say the demand curve is fairly flat. Something like salt would be that way. So I think I think it's true if I spend so little money on salt. I don't even think I would notice. I can't even tell you what the price of salt is. If it went up by 50%, I don't even think I would notice it. And I don't think I would change my quantity demanded by much at all. Let's say, though, I would decrease my salt consumption by 1%. Okay. So if that's true, my percent change in salt consumption, percent change quantity demanded is negative 1%. Okay. If that's true, in this case, the elasticity for Tim's demand for salt is negative 1 divided by 50, and that means that equals negative 0.02. Okay. So there's a first test question that could be, what if I give you those facts? Price of salt goes up 50%. Tim decreases the salt consumption by 1%. What is Tim's demand elasticity for salt? And the answer is negative 0.02. By the way, we economists often forget the negative sign, and so we'll say something is inelastic if something is small. By that we mean it's close to zero. We're often talking about the absolute value of the elasticity. So what we often say is something is a good is the demand is inelastic if and only if the elasticity, and actually I've already forgotten the negative sign, the absolute value of the elasticity is less than 1.0, and we'll say it's elastic if the absolute value of the elasticity is greater than 1.0. And then you may ask, well, what if it actually equals 1.0? The book says that. We call it unit inelasticity. I don't care about that. That will not be on the exam. You're welcome to forget completely. So in my class, all elasticities are either going to be greater than 1.0. The absolute value of the elasticity is going to be greater than 1.0 or less than 1.0. Okay, never equal. Okay, another possible test question. Okay, let's see. Here's one. I'm going to write this in red. This test question. Okay, what if I instead I told you the elasticity for pepper equals negative 0.3. Okay, this time I remembered the negative sign. It was negative 0.3. Suppose the price of, and so the elasticity, let's say it's a particular consumer, Tim's elasticity is, elasticity of Tim's demand for pepper is negative 0.3. Suppose the price of pepper increases by 40%. What happens to quantity demanded? That is, by how much will Tim's quantity demanded of pepper increase or decrease? Okay. The way you do that is you just use the formula for elasticity. So we started off, I gave you that the elasticity for pepper is negative 0.3. So the elasticity equals negative 0.3. Okay. And then I told you that the price of pepper increased by 40%. Okay. So change in price increased by 40%. What happened? What happens to the quantity demanded? Okay. Let me use blue to give the answer. So now it's just an algebra problem. We have negative point, let's call that the quantity demanded, let's call that x. Negative 0.3 equals x divided by 40%. Okay, so this is now just an algebra 1 problem. X equals negative 0.3 times 40%, and I get that equals negative 12%. Okay, so the answer to that would be, so what happens to quantity demanded? The answer was negative, so the answer is quantity demanded goes down by 12% if we're given those facts. Okay, elasticity is negative 0.3. Change of price is price goes up by 40%. Okay, so there's a possible test question. Okay, I want you to think finally about elasticities and a general rule. And this is when there's when elasticities are close, when elasticities are close to zero, usually the good has few substitutes. And the reverse, when the good has few substitutes, usually its elasticity is close to zero. We'll say it's an inelastic good. Now, I've already given you one example. I talked about what happens to me when I look for gasoline. Okay, actually, there's not many substitutes for gasoline. You could buy kerosene, or I don't know. Maybe there's something else that works in my car, but I don't know. All I know is gasoline. There's hardly any substitutes for gasoline. So there's few substitutes for gasoline. My elasticity for gasoline is going to be close to zero. It's going to be pretty inelastic, my demand for gasoline. But meanwhile, I said, what if we made the good very, very particular? Instead of gasoline, we called it Sunoco gasoline from the University Mall gas station. Okay, very particular subset or very particular case of gasoline. Now, I have really good substitutes for that because I can just get that at any other gas station in Fairfax. Okay, so with that case, there are lots of good substitutes, and so in this case, my elasticity is not close to zero. The absolute value of the elasticity is going to be pretty high. Okay, and then the book gave an example, or said, look, if we think about all SUVs, um, some SUVs are American made. Okay. So meanwhile, there's some SUVs that are not American made. These are the SUVs that are American made, and then of the SUVs that are American made, some of those are going to be Chevy SUVs. Okay. Now, the book didn't do this, but we could add something to this to make this even more interesting. Let's talk about all motorized vehicles. Okay, so something like this. This is all motorized vehicles. Okay. Now, if I want a vehicle, a motorized vehicle, there's really not much of a substitute for that. Scooter or bicycle, something that's hardly going to work, especially if I'm driving 6 miles to work, or driving 15 miles to my kid's sports practice. Okay, I can't use a scooter or a bike. I have very few substitutes. I guess you could say Uber or taxis. Maybe they're almost a substitute, but if the good is all motorized vehicles, there's really not much of a good substitute. Okay. Meanwhile, though, if it's an SUV, okay, if I have an SUV, I have a good substitute, just a regular car or a pickup truck, or some other kind of motorized vehicle. Those are pretty good substitutes. But they may only be moderately good substitutes because I may have a strong taste for SUVs. Okay. On the other hand, if the good is an American SUV, there's probably more substitutes for American SUVs than just the broader category of SUVs, because I probably don't care that much if it's an American SUV versus a Toyota SUV, a Japanese or a German SUV. They're probably, the car runs just as good, feels just as nice. And therefore, those are really good substitutes. And then even better, even if I had a taste for American SUVs, if I had a Chevy SUV, then there's probably even really, really, really good substitutes for a Chevy SUV, another American made, a Ford SUV. So that's the idea, okay? When we start making the good more and more particular, usually there's better and better substitutes for that case. So when that happens, when the good has a lot of substitutes, the opposite, when the good has few substitutes, when the good has a lot of substitutes, the elasticities are far from zero. So the absolute value is high. Okay, so we'll say that when we have a very particular good, we'll say the elasticity is very great. Okay, or actually, if we're careful, we'll say the absolute value of the elasticity is very great. Okay, so keep that in mind. The key is if we have something about a question on an exam, we'll say, do you think the elasticity of this is high or low? Usually, what we'll do is look to see if it's a very particular good, which will have lots of substitutes, or a very general good, like water or motorized vehicle, which there are not many good substitutes. Okay, in that cases, the elasticity will be close to zero. Okay, so that was part C. I'm going to do one more part, and we're ahead of things. I've done most of chapter 3, and I've allowed one more session, so I'll do that later. I was going to do some questions from the book. Instead, what I think I'm going to do for part D, I'm going to do one more example from the law of comparative advantage. I think that was a hard problem, and I think it's worth doing one more example from that. So that's in part D. If you already understand that, you're welcome to skip part D. Okay, see you there at part D, maybe.